Hi everyone, today we'll be covering on parameterization in Data Factory, which is extremely useful as it helps to save a lot of time and allow reusability of pipeline logic and assets. Following that, we will be doing a hands-on demo on how you can parameterize your pipelines. Let's get started. The three components of parameterizations are parameters, variables, and expressions. For parameters, they simply serve as an input for your pipelines, which are defined dynamically by you. These input parameters will then be used in the pipeline to control the behavior and activities as the information is passed on. As for variables, they are temporary values that you use within the pipeline and the execution of your workflow so that you can store and use these temporary values and make an execution of the workflow. Lastly, for expressions, they are basically JSON-based formulas, which means JavaScript object notation that you use and execute either parameters or functions to do some conditional formatting or execute some code so that you can modify parameters and variables. If you remember our scenario from the previous video on Azure Data Factory, we had actually used the taxi.csv file and built the copy activity pipeline to load the taxi.csv file into the taxi table in the SQL database that we've created. For that, we needed to create a taxi.csv dataset and a taxi table dataset to match our source and destination. The issue arises when you want to load another file. For instance, let's say you want to load another file called games.csv. Within the pipeline context, you will need to create a new games.csv source and sync dataset, as well as adding one more activity to copy this data. Now that is an additional 3 objects created in the pipeline for one file. So if you have 20 additional files that you like to load, that is an additional 60 objects that you will need to create in the Azure Data Factory. As you can imagine, that is not the best way to approach this. The idea here is that you can actually parameterize datasets. To do so, you just need to define a parameter on a dataset like in the following diagram. As you can see from the diagram, we only need to create one dataset for the source and one dataset for the sink, while the copy activity can be reused as the datasets have been parameterized. So how does it work? As you can see from the diagram, when the parameters has been defined, which are taxi.csv and games.csv, these values will pass into the parameters pipeline. The taxi.csv and games.csv will then be passed into the pipeline to parameterize on your source and sink dataset. Therefore, when these values are passed into pipeline externally through execution, this means that your copy activity will only need to be created once as the values has been parameterized. If we were ingesting 10 files, these two simple actions will save us plenty of time from making additional 30 objects as we are using parameterized pipelines. Now that we better understand how parameterization works, let's head over to Azure portal and start creating our parameterized pipelines. So in this demo, I'm going to be assuming that you have already watched my previous video on Azure Data Factory pipelines or that you already know a bit about Azure Data Factory. Therefore, for the purposes of this demo, I've created a resource group called ADF Demo RG, where I've created several Azure resources. I've created an Azure Blob Storage, SQL Database, and SQL Server, as well as Azure Data Factory. First, let us head over to the Azure Blob Storage and create our container. So let's name our container as input, and subsequently, let's upload our CSV files into the input container. As you can see, it's pretty quick to upload the games and taxi CSV. Now let's open one of the CSV. As you can see, the data is in a very familiar format that we all know, which is in CSV. Now that we have uploaded the CSV files, let us head over to the SQL database to create our games and taxi tables. Let's click on the Query Editor blade and log in using our credentials. As you can see, after clicking the tables drop-down, there are no tables in the database. And I've created the script for the creation of the two tables for games and taxi. So let us run this query. As you can see, the query has succeeded, and let's refresh this. Now you can see that the two tables have been created with the respective definitions that we have provided with the create table query. Now that we have uploaded the files into the blob storage as well as creating the tables on the SQL database, let us head over to the Azure Data Factory and create our parameterized pipelines. So let's head over to authoring and create a new pipeline. Under the move and transform activity, let's bring out the copy data activity into the canvas. As you can see, for the source dataset, we have yet to create it. So let's go ahead and create our source dataset, which is in the Azure Blob Storage. And let's select CSV delimited text as the format and rename it as Blob Storage Dataset. For the link service, we have yet to create, so let's go ahead and create it too. For the authentication type, we can leave it as account key, and for the subscription and the storage account name, let's select the storage that we have created under the same resource group, and let's test the connection. Connection successful, so let's go ahead and create it. For the file path, let's select one of the CSV files that we have inputted. Let's select game CSV. And we can leave first row as header as checked and import schema to be selected as from connection store. Let's go ahead and click OK. And let's create the sync data set for our data pipeline. For the data set, for the sync data set, it will be the Azure SQL Database. And let us rename it SQL Database Dataset. As for the link service, let us create a new link service to the SQL database. Select the appropriate Azure subscription and server name as well as the database, and key in your Azure SQL credentials. Let's test the connection. Connection successful. Let's go ahead and create the link service. As for the table's name, let's select games as we selected games for the input blob dataset. And we will leave import schema as from connection store. And let's go ahead and create. Now that we have configured both the source and sync dataset, let's go ahead and run this pipeline and see if it's running successfully. If this pipeline runs successfully, we'll be able to see the blob storage data for game CSV being populated in our Azure SQL database. Looks like the status is completed. Let's head over to our Azure SQL database to check on our games table. As you can see, the game CSV file has been nicely ingested into the game's SQL database table. Now let's head back to Azure Data Factory. So now I think it will be an ideal time for us to parameterize because at this point, we know that our copy activity, datasets, and connectivity works just fine. So first of all, let's head to our source dataset and click open. As you can see, the file path is explicitly defined as games CSV, and we want to parameterize this value so that the datasets are taking input parameters dynamically. So let's go ahead and remove the games CSV and click on dynamic content. Under the parameters section, this is where we will define the custom parameters. Let's click on the plus icon, and this is where we will be defining the parameter, which will be called file name. We will leave the default value as blank. Now that we see the file name parameter that we have just defined, so let's click on it and you can see that it appears in the expression builder. As you can see, it has added dataset file name, and this means that whatever we pass into this dataset as a parameter, it will be used for this file path. Let's do the same for the sync dataset. Under the table section, let's click on the checkbox and enter manually. Let's remove the games table name and click on dynamic content. Let's define the new parameter as table name and leave the default as blank again. Once again, now we can see that the table name parameter that we have just defined, so let's just click on it and you can see that it appears in the expression builder. Now we have two data sets that both take parameters, where one takes in the file name parameter while the other takes in the table name parameter. Do you notice something interesting here? This is because we created the parameters for this dataset. Let's define the file name in the source dataset to be taxi CSV, and subsequently, let's define taxi as the table name. We are ready to run the pipeline to ingest the CSV file into the taxi SQL database. Before that, I want to show you that the taxi table is empty in the SQL database. So let's go ahead and run this pipeline. As you can see, the copy data has succeeded and it has landed in the Azure SQL database. Let's check the taxi table once more and run our query. It looks like the taxi CSV is nicely populated into our taxi table in the SQL database. Let's also see the amount of rows in our taxi table. So I'm going to run a select count query. And as you can see, there are about 6,404 rows. The next thing that I want to show you is pipeline parameters. In order to define parameters on a pipeline level, you will need to click on this white canvas. So if you have anything selected, you need to go ahead and click on the canvas. Following that, you will be able to see the pipeline parameters tab. So let's go ahead and click on new. We are going to create two parameters called file name and table name. So why are we defining the same parameters like previously? Well, this is because we want to define them once again on the entire pipeline and pass them down into each dataset. Now that we have a file name and a table name, we are going to use these pipeline parameters instead of typing the taxi CSV or the table name at the dataset properties here. We will remove this part and click on the dynamic content and let us click on the parameter called file name. As you may have noticed, the expression is directed to the parameter that we have defined at the pipeline level. Let's head over to the sync dataset and change the value using the dataset parameters. Let's click on the parameter called table name. This once again is a pipeline parameter. So what we did just now is that we have defined the parameters on the pipeline level, which will then be passed down into our dataset as well as our copy activity. So I'm going to hit debug now and you'll ask me for those pipeline parameters that we previously defined and we also didn't supply any default values. Therefore, I'm going to pass in the file name called taxi CSV, and as for the table name, I will supply taxi and then we'll click OK. Now that the pipeline has finished running successfully, if we were to go back to the SQL database and rerun the query, we're going to see that the number of rows have doubled because the taxi CSV file has once again been ingested successfully into the SQL database. So let's head back to Azure Data Factory. So the next thing that I want to show to you is how we can reuse the pipeline parameters that we have previously defined as well as use variables. Let's say we want to back up the taxi table into a CSV file that will be called taxi export CSV file, and I also would want the current timestamp to be in the file name itself. So let's bring another copy data activity and put our source as SQL database and add the pipeline parameter table name into the dataset properties value. Subsequently, let's do the same for the sink dataset. We will use the blob storage as the sink and add the pipeline parameter file name into the dataset properties. Next, you have something called variable that you can store value, and I want to store the current time so that I can add that to my file name. So let's drag the set variable activity into the canvas and let's name it as current time. In our expression builder, let's go to the functions tab. As you can see, there's a wide variety of functions that you can use to manipulate your variables or parameters. Let's choose the UTC-now function as it returns the current timestamp as a string. Let's join the activities in succession so that it will be executed sequentially on success. Now that we have the timestamp, let's modify our expression for the export activity. Let's concatenate the file name, the string exported, the current timestamp variable, as well as the CSV file extension. Now as you can see, I've added the CSV file extension, so we need not pass the CSV extension as a parameter, but it will be appended dynamically. So let's make it consistent for our first activity too and append the CSV file extension to our source dataset expression. Okay, now we are ready to run the pipeline again, and let's pass the taxi value into both the file name and the table name to run. Now that the run has succeeded, let's head over to our blob storage. And as you can see, we have a taxi exported CSV file with the current UTC timestamp on it. This is amazing because you are reusing the parameters and objects, as well as using expressions to control the flow, which would take a lot of time without this knowledge. That's it for this video, and if you like this video, hit the thumbs up or leave a comment and subscribe. See you next time.